Hello Year 5, Miss Warren here. I hope you're well and welcome to your Tuesday lesson for maths. Now today we're going to be having a look at a few reasoning and problem solving questions, so let's get into it.
Okay, so this is the starter task. You have 4 questions here that I'd like you to work out. Your first question is, what is 253 times by 3? Your second question is, work out the area of the rectangle. Your third question is, what is 10 squared? And your fourth question is, what is 100 more than 9,308? So pause the video here, work out these questions. So it's your turn, off you go. Okay, welcome back. Hope you had some time to work through these questions and now here are the answers. So your first question is 759. The area of the rectangle was 4 times by 5, which is 20 centimetres squared. Your third question is what is 10 squared, which is 100. And then for what is 100 more than 9,308, which would be 9,408. So well done if you got all those right, and now let's move on. So the learning objective today is to use skills learnt to answer a variety of questions with reasoning and multiple solutions. So you're going to have to know your place value, adding and subtracting, multiplying and dividing, factors, multiples, reasoning and solutions. You might also need your square number and your prime number knowledge as well. Okay, so today's lesson is going to be structured a little bit differently. There are going to be 3 different reasoning multiple solution questions that I want you to answer. The first question is the easiest, the last one is the hardest. It's whatever you feel most comfortable in doing. If you are finding any of them tricky, I have got some extra support slides a little bit later on. If you'd like a bit more of a challenge, then I have extension challenges for you to complete. And then at the end, I have answers for the questions as well. So this is the first question called Magic V, and you need to place each of the numbers 1 to 5 in the V shape so that the 2 arms of the V have the same total when adding diagonally. So you need to put in each of the circles a number from 1 to 5, and you cannot repeat the number twice. How many different possibilities are there? Can you convince someone that once you've finished that you have found all the solutions possible? The skills you'll need for this are addition, subtraction, estimation, problem solving and reasoning. So I want you now to pause the video here and try and see if you can work this question out. If you are struggling with this question, a little bit later on there will be some extra support. If you want an extra challenge with this question, there will also be an extra challenge for this question too. So why don't you try and pause the video here and work this question out. The second challenge is, Flora has challenged her friends. She asked, can you make square numbers by adding 2 prime numbers together? Ollie had a think. Well, let me see. I know that 4 equals 2 at 2, and 2 is a prime number. Why don't you have a go yourself? Try with the first 12 squared numbers. So what you need to know are your square and prime numbers. You need to have your addition and subtraction, estimation, reasoning and problem solving. So you need to find the first 12 squared numbers. You will also need to know your prime numbers all the way up to 100 and maybe even further than 100. So you might need to have a bit of a Google search there to work out whether you can add 2 prime numbers together to make a squared number. So pause the video here if you're going to work out this question. And like I said before, there will be extra help if you need it a little bit later on and an extra challenge. So it's now your turn, off you go. And this is the final question. Now, this is split over a couple slides so I can really talk through this question. So, can you order the digits 1, 2 and 3 to make a 3-digit number which is divisible by 3? And when the final digit is removed, again, it becomes a 2-digit number divisible by 2. And then finally, a 1-digit number divisible by 1. So that's the first part of the question. The second part of the question is, can you order the digits 1, 2, 3 and 4 to make a 4-digit number which is divisible by 4? And when the final digit is removed, it becomes a 3-digit number which is divisible by 3. And when the final digit is removed, again, it is a 2-digit divisible by 2. And then when there's 1 digit left, it's divisible by 1. So this is the first 2 parts. The final part is this. Can you order the digits 1, 2, 3, 4 and 5 to make a 5-digit number which is divisible by 5? And when a final digit is removed, it becomes a 4-digit number divisible by 4. And when the final digit is removed, it becomes a 3-digit number divisible by 3. And when the final digit is removed again, it becomes a 2-digit number divisible by 2. And then finally, a 1-digit number divisible by 1. So I'm going to show you using the example of the 1, 2, 3. So can you order the digits 1, 2 and 3 to make a 3-digit number which is divisible by 3? And when the final digit is removed again, it becomes a 2-digit number divisible by 2, and then when one digit is removed, then it's divisible by 1. So I've ordered my numbers 1, 2 and 3 into the number 231 here. Now I need to start off by figuring out whether this 3-digit number is divisible by 3. Now, there are tricks to doing this. You could add up all of the digits together, and if it is a multiple of 3, then you can divide it by 3. So 2 add 3 is 5, add 1 is 6. 6 is a multiple of 3, therefore this number would be divisible by 3, but we can work it out just to double check. So I'm going to do it in short division, and I'm going to put my 3 here. How many 3's into 2? 0 3's into 2. So I'm going to cross out my 2 and put my 2 above my 3. How many 3's into 23? I'm going to go in my 3 times table now. 3, 6, 9, 12, 15, 18, 21, 24. Well, 24 is too high, so it's 21. So it's 7 3's with 2 left over. Well, I know that 7 3's are 21, so I know that 7. So the number 231 is divisible by 3, as my answer is 77. So that first part I can do. So I'm now going to get rid of all of my working out because I don't need it anymore. Then the second part of my question, when the final digit is removed, so I'm going to remove the 1, it becomes a 2-digit number divisible by 2. Well, my 2-digit number here I have is 23. Now 23 is an odd number, therefore I know it is not divisible by 2, so this doesn't work. So this number 231 does not work. So I would need to think about rearranging these numbers into another 3-digit number that is able to be divided by 3, and then when it's a 2-digit number divided by 2, and then when a 1-digit number divided by 1. It was the same with the other 2 questions. If you have the numbers 1, 2, 3, 4, making a 4-digit number, and then the other number, which is 1, 2, 3, 4, 5, making a 5-digit number, and then working through the steps. I'm now going to show you all the questions again. So these are the first 2 questions, so pause the video here and write those down, and then work them out for me. And then this is the final question here. Again, pause the video here and work it out for me. If you are struggling, like I said before, there will be extra help a little bit later on. Okay, so here is the extra support. So this is the extra support for the Magic V question. You could start off by having cutouts of the numbers 1 to 5 so you can maneuver them around a little bit easier. You could start with having a number at the bottom of the V, which would be in this circle here. And then you're able to work out both sides by trying to make them the same. This might take a lot of trial and error. So that is some support for the Magic V question. Then some support for the finding 2 prime numbers when added together to make a square number. So the extra support here is 3 of Flora's friends have some ideas. Bailey said, I made the square number out of cubes and tried taking a prime number of cubes away to see if I was left with a prime number of cubes. So that was a lot of trial and error. So what they had is they had little cubes. You could equally do it by drawing the square number in a square and then crossing out prime numbers away from it, seeing if you can try and make a prime number left. Dinah said, I wondered whether noticing that 2 is the only even prime number was important. And then Charmaine said, I listed the prime numbers up to 100 and then listed the first 12 squared numbers. So what Charmaine here has is she's got all the prime numbers and all the square numbers together and then is able to do some trial and error. So that is the support for the 2 prime numbers added together to make a square number. So this is extra help for the 1, 2, 3 ordering question. So you could place your numbers into a place value grid or structure work out in stages. This will provide organisation to your working out. So you could have your first or 3-digit number, then your 2-digit number, then your 1-digit number. Same with your 4 and your 5-digit number. What makes a number divisible by 1, 2, 3, 4 and 5? So if you know why a number is divisible by those numbers, then that will help you when ordering your numbers. Where do the even numbers need to go in the number? And about the odd numbers too. Where does the 5 have to go if you're dividing a number by 5? And what could you do if you're stuck? What types of things could you do or use around your house if you are unsure or stuck? You are able to use different equipment or resources if you really need to. These are extension challenges for the first 2 questions. I'm not going to give an extension challenge for the last one, as obviously there's multiple steps to it and is a little bit trickier. So for the Magic V, the extension challenge is to consider the combinations you have created, what is same, what is different about each one. Use 5 different consecutive numbers, maybe even try negative numbers to create a Magic V. Increase the number of circles or numbers. Could you do a cross instead? Could you create a multiplication V where multiplying numbers from 1 to 5 make both sides the same number? So pause the video if you want to do the extension challenge for the Magic V question. And for the question, find 2 prime numbers that when added together make a square number. The extension challenge is, could you see if you could add 3 or 4 prime numbers together to make a square number? Could you find the squared numbers up to 15 squared and find the prime numbers that when added together make those numbers? You might need prime numbers bigger than 100 like I mentioned earlier. Pause the video here if you're going to do this extension challenge. Now I'm going to be showing the answers to the questions, not including all of the extension questions, so don't move any further if you haven't answered all of your questions. Okay, so this is the answer for the Magic V question. I know there's a lot of information here, so I'm just going to read it out for you. So if we have the numbers 1, 2, 3, 4 and 5, and our original goal is to arrange all 5 numbers in a way that the 2 arms have the same total, if we get the total of all the numbers together, it's 15. So in the middle, we must have an odd number, because if we have an even number, say for example 2, 15 take away 2 is 13, and now 13 is not divisible among the other circles, as it is a prime number. So if we pick 1 as the middle number, then each side is required to have a total of 7. If we have 3, then we need a total of 6 on either sides. If we have a total of 5, we have 5 on either sides. So just to kind of explain how these numbers are laid out, 5 and 2 are in the top 2 left-hand side, 1 is in the middle, and then 3 and 4 is going at the other side. So those are all the possible ways in which you could have had the Magic V laid out. And then for the 2 prime numbers added together, yes, it is possible, and this is what I've got. So those are all of the numbers up to 15 squared. And then for the problem 1, 2, 3, for problem 1, the number would have been 1, 2 and 3. Problem 2, there is no solution. As you can see, I've worked it out. And then problem 3, your number would be 34,125, as obviously I've worked out the other ones as well.
And that is it for today's lesson. We have looked at a variety of different questions that we use different skills to answer them. I shall see you tomorrow for another maths lesson. Stay safe, year 5.